Well, uh, let's move on. And now we will speak about theodolite traversing. Well, in this slide, you can see the main tasks of geodesy. This is determining the shape and size of the Earth, establishing reference frames, mapping the Earth's surface, measuring distances and angles. And speaking about main land geodetic techniques nowadays, the theodolite traversing is one of the best geodetic technique that we can use on the territory while global navigation satellite systems signal is not available. It can be, for example, in the middle of the city with huge high buildings where radio signals from satellites goes to our receiver with distortions. In any case, theodolite traversing is more precise than global navigation satellite systems. Another four important tasks for modern geodetical sciences is monitoring the changes of the Earth's surface, so-called geodynamics. Geodesists monitor changes in the Earth's surface over time, such as subsidence, crustal movements, sea level changes, and we use different techniques, including satellite-based radar and laser measurements. Next important geodetic task is developing geodetic models. We develop models of the Earth's surface and gravity field to improve our understanding of the planet and its geodynamic processes. Another task supporting navigation. We provide accurate positioning information for navigation purposes, such as for ships, aircrafts, and land vehicles. And last one, supporting geophysical research. We support geophysical research by providing accurate measurements of the Earth's gravity field, which can be used to study the Earth's interior and its geodynamic processes. Speaking about practical geodesy, that, for example, engineering geodesy or building surveying. Building surveying involves the inspection, assessment, and management of buildings and structures. Some of the main tasks are building inspections. Building surveyors carry out inspections of buildings to identify defects, damages, and potential hazards. They also check compliance with building regulations, codes, and standards. Building condition assessment. Building surveyors assess the overall condition of buildings to determine the structural integrity, maintenance needs, and remaining surface life. Building energy assessments, building maintenance and repair, project management. While we decide to begin the construction of building or structure, building surveyors manage construction projects, including building refurbishment, renovation, and so on. Building conservation. Building surveyors provide advice on the conservation of historic buildings and structures, including preservation, restoration, and repair. Building valuation. It's another kind of very close work to geodesy. Building surveyors provide valuation of buildings for various purposes such as insurance, taxation, and sale. Health and safety assessments. Building surveyors carry out health and safety assessment of buildings to identify potential hazards and recommend appropriate measures to mitigate risks. Environmental assessment and expert witness services for legal disputes involving building defects, damages, or other building-related issues. Speaking about theodolite traversing, we can begin our understanding this traversing. The system of surveying in which the angles are measured with the help of theodolite or total station is called theodolite surveying. Theodolite is used to measure the horizontal and vertical angles. Here you can see construction worker or geodesist with theodolite. The theodolite is standing on a tripod. Every theodolite is more precise than magnetic compass. Magnetic compass measures the angle up to as accuracy of 30 minutes. However, a vernier theodolite measures the angles up to accuracy of 10 seconds or 20 seconds. Nowadays we have more precise theodolites with micrometers that allows us to measure the angles up to accuracy to maybe 5 seconds and more precisely. There are variety of theodolite vernier, optic, electronic, etc. Well, what is the principles of theodolite using? First of all, theodolite allows to measure horizontal and vertical angles. Another task, location points on a line. Prolonging survey lines, finding difference of level, setting out grades, ranging curves, tachyometric survey, or tachyometric means very quickly survey, while comparing with another methods. Tachyometric surveying is one of the quick surveys. Measuring of magnetic bearing. In this slide you can see this theodolite that is standing on tripod in point 1, and then we can see a ruler. It's wooden of aluminum rod of 3 meter length, And while we are looking at this rod, we can see the distance between two horizontal lines in our uh, um, in our glass, in our spyglass that we can use in this theodolite. And while we move the rod on the different distances, the S1 lengths become larger while we move this rod far away from theodolite. So we can measure with not very high accuracy the distance between the theodolite and this ruler or rod that we use to measure distances. This is a principle of optical lens meter. Definition. The first step of working with theodolite is centering. Centering, it is a process of setting about the theodolite exactly over the station mark, and we call this process centering. Transition. The transition is process of turning the telescope about its horizontal axis in a vertical plane through 180 degrees is termed as transition. Transition. Face left. If the vertical circle of the instrument is on the left side of the observer while taking a reading, the position is called the face left. You can see in this photo two columns of the theodolite. The one column is bigger, so inside this column we can find a circle, a measurement equipment that allows us to measure vertical angles. And then while this vertical circle is on the left side, we can call this position of the instrument face left. Face right. If the vertical circle of the instrument is on the right side of the observer while taking a reading, the position is called the face right. For example, this observer, you can see vertical circle. Now it is in the right position. So we call the position face right. Changing phase. It does not mean that observer use kind of mask. He don't change his appearance like Hollywood actor or actress. It is an operation of bringing the face of the telescope from left to right and vice versa. How can we change the face? We turn our telescope on 180 degrees and then turn the transit our instrument to the point of interest. Swinging the telescope. It is the process of turning the telescope in horizontal plane. Vertical axis. The vertical axis is the axis about which the instrument can be rotated in a horizontal plane. When the vertical axis goes through the center of instrument, through the center of tripod, and must be not far from the geodetic mark on the ground below the instrument. So the vertical axis is when we create the projection of vertical axis on the horizontal plane. This vertical axis becomes a point in which our legs of our traverse joined in this point. So it's a top of our angle. Line of collimation. We can speak about line of collimation of plane of collimation. It's an imaginary line passing through the intersection of the crosshairs at the diaphragm and the optical center of the object glass and its continuation. So, while we are looking at our goal, our mark, geodetic mark in the distance, our line of our sight is a line of collimation. While we turning the telescope up and down, this line of collimation creates the plane of collimation. Another definition, axis of the plate level. It's a straight line tangent to the longitudinal curve of plate tube at its center. Plate level is equipment that allows to turn our vertical axis in true vertical vertical axis must be vertical, and plate level helps us to do this process. Well, in the slide we can see the main parts of vertical transit theodolite. First of all, vertical axis. It goes through the instrument, and the upper part of the theodolite, so-called alidad part of the theodolite, is rotating around this vertical axis. In Russian and Ukrainian literature, we call this vertical axis often the axis of theodolite rotation. While we try to rotate the theodolite and to see different points of interest, so we rotate it around the vertical axis or around the axis of vertical rotation. Objective. Objective is a part of a telescope that helps us to see our object. All this observation tube or spyglass or telescope, we use its complex. It's a complex part of theodolite which contains a lot of glasses, and all these glasses allow us to see good picture of the object in the eyepiece. We position our eye not far from the eyepiece and see through a telescope on our object, and we finally we can find the main direction to this object. The air sirens begin, so I ask everybody to go to shelters, and when the sirens will end, we can continue. Just few seconds I explain the another parts of vertical transit theodolite. It's a vertical circle that allows, it's a kind of a circle with degrees marked on its surface. It helps us to measure vertical angles. Plate level is equipment that allows us to put our vertical axis in vertical position. Upper plate, it's upper part of theodolite that rotates. Vernier, it's a kind of equipment that helps us to measure the horizontal angles. Lower plate, it's a part of theodolite that stays still while we rotate in the upper plate, or alidad plate. Inner spindle, it's part of equipment that helps us to rotate the theodolite. Outer spindle, Treibach. Treibach is a part of theodolite that allows us to put it on a tripod and to put the vertical axis in vertical position using leveling screws. The tripod is a head of the tripod. And you can see legs of a tripod.